Καλημέρα σας. Ευχαριστούμε που ήρθατε σήμερα πάλι στο συνέδριο. Έχουμε τη χαρά και την τιμή να φιλοξενούμε μαζί μας μια σημαντική ερευνήτρια, καθηγήτρια στο Winnipeg University στο Καναδά, την καθηγήτρια Zahra Moussavi, η οποία θα μας μιλήσει σε θέματα που έχουμε σχέση με την ανίχνευση της άπνοιας του ύπνου, ένα φαινόμενο που δημιουργείται κατά τη διάρκεια που κοιμάται κάποιος. Και η Zahra Moussavi έχει πολύ μεγάλη εμπειρία στην ανάπτυξη αλγορίθμων, κυρίως στην επεξεργασία αναπνευστικών σημάτων, όπως ήχους αναπνοής, ακόμα ήχους από ρυθμούς αναπνοής και πώς μπορεί κανείς από τους ήχους να βγάλει τον όγκο τον οποίο εισπνέει κάποιος. Έχει ασχοληθεί ιδιαίτερα με την ανάλυση σημάτων κατά τη διάρκεια του ύπνου και πώς μπορεί κανείς να βγάλει πληροφορίες συσχέτισης του εγκεφάλου με το αναπνευστικό ρυθμό και πώς αυτά εμφανίζονται κατά τη διάρκεια του ύπνου σε φαινόμενα άπνοιας. Και τα τελευταία 5-6 χρόνια έχει στραφεί πάνω στην ανάλυση και επεξεργασία σημάτων που προέρχονται από ασθενείς που πάσχουν από Alzheimer. Οπότε σήμερα θα μας μιλήσει για αυτό το κομμάτι που αφορά την αποφρακτική άπνοια. Το βιογραφικό της το βλέπετε στο πρόγραμμα. Είναι επίσης Distinguished Lecturer της IEEE. Η IEEE κάθε χρόνο βγάζει μία λίστα από διακεκριμένους ομιλητές, τους οποίους θεωρεί ότι προάγουν το έργο στον τομέα που βρίσκονται και τους βοηθά να έρχονται όλοι σε επαφή με διάφορα τμήματα. Και έτσι, σε συνεργασία και με την IEEE, το chapter που έχουμε εδώ, προσκλήθηκε η καθηγήτρια Zahra Moussavi, η οποία πιστεύω ότι θα δώσει ένα διαφορετικό τόνο, ακριβώς για να δείτε τι γίνεται στην έρευνα στον Καναδά. Είναι στο Winnipeg University, όσοι δεν γνωρίζετε, είναι προς τα αριστερά του Καναδά, βέβαια με πάρα πολύ χαμηλές θερμοκρασίες το χειμώνα, αλλά πολύ ενδιαφέροντα εργαστήριο και σε συνεργασία με πολύ μεγάλα κέντρα όπως το Mayo Clinic, το McGill University ή ακόμα και το John Hopkins. So, Zahra, the floor is yours.
Good morning, everyone, and thank you, Dr. Hajitiadialis. I finally learned how to pronounce your last name very well. Okay, thank you very much for the invite. It is my honor and great pleasure to be here. And I must say that I didn't understand how what you said on my backgrounds. You probably introduced where I'm coming from, right? About the...
Yes, I introduced you, and also what is the field and your collaborations, and that you are also distinguished lecturer from IEEE.
Okay, thank you. Well, yes, as Dr. Leontiu said, I'm electrical engineering by training in bachelor. And then during master Ph.D., my focus degree was again in electrical engineering, but the focus of the research was in biomedical engineering. And just a little bit of introduction from where I'm coming from. I'm from Winnipeg, and these pictures depict Winnipeg in both summer and winter. Your weather today is our summer, basically. When I left Winnipeg, still we had about 1 meter of snow in my backyard. It was -6 though. Our spring is about -6 to +10 maximum. Summer is like today, basically. And yes, this is the University of Manitoba, the university that I am working with. Again, the left side is the summertime, right side is the winter. We have quite energetic young people who always bike to school even in winter, even in snow, -40, -60. And I always say that we have good students is probably due to the weather. There is nothing else to do. So they all just go to school and that's it. Even in summertime, it is very short, so there is basically nothing else to do than studying in Winnipeg. Okay. And this is the website of our Biomedical Engineering Program. I'm quite proud of this program because I pushed for it to establish for 7 years, and after finally 7 years, now we have a Biomedical Engineering Program, which is only graduate program, not undergraduate. But we offer master and Ph.D. with the biomedical engineering degree. And that's our website. Okay. My main research at U of M, nowadays I'm focusing only on 2 main areas. One area is respiratory sounds analysis for respiratory disorders, in particular sleep apnea, which I'm going to talk about. And the other main research area is development of the virtual reality environments, navigational virtual reality. That's the part that is a little bit innovative in it. And we use it for diagnostic as well as rehabilitation of neurodegenerative diseases, in particular, again, Alzheimer. I keep both fields quite in parallel. Actually, recently, due to the treatment of Alzheimer, we are again connecting Alzheimer studies with the sleep apnea too. I'll talk about it later as I go. This is an example of the virtual reality environment that we developed for the diagnostic purpose. It is testing orientation capability. We have 2 types of orientation, egocentric, allocentric. This one is testing only basically our internal compass, how well we can orient ourselves in an environment that there is no landmark, no cue. So we have to rely on our left, right, front, back. And I'm hypothesizing that this is one of the first capability that goes wrong with the Alzheimer patient. So we designed this navigational environment in which, I'm not sure how well you can see from your viewpoint, but in this environment, the subject, the patient can navigate inside this building and go find a target room. We designed a wheelchair to run to do the navigation. The main reason is because people my age or older, if we use joystick to play a navigational virtual reality, we all get dizziness, headache. You young people play with joystick in the games and you have no problems, but in our age we have problems. So, and the reason is obviously the lack of harmony, the lack of synchrony between visual input and the vestibular response. So we designed this wheelchair, which basically replaces the joystick. And when you walk the wheelchair, you are walking indeed in the virtual domain. The version that this old lady is doing is the version that still doesn't have a goggle. She sees the virtual reality in the laptop and either sits in the wheelchair or walks it. The new version is the one that you see right now. Let me play it. Okay. This is still not the last version because this is a goggle that now we have replaced it with Oculus Rift. How many of you know what is Oculus? Okay, many, yes. So we wrote the program to be displayed in Oculus. And if it were run in Oculus, I'm sure you would notice that you cannot see on the screen like this. You would see 2 distorted images overlapped. But the video for that is on the YouTube. I didn't bring it with me on the USB. Anyway, with the Oculus, again, when you put it on, you basically see nothing but the virtual domain, and you can freely walk in it. We still use wheelchair, both for a safety mechanism and also so that people don't hit anywhere and it provides a little bit of a stability. I'll say one more thing here and then go to a sleep apnea, to the main talk. This is quite a large project. I didn't think that it would be such a large project, large environment, because I didn't know the technical challenges. But as we started it, we realized that it is way bigger than we thought at the beginning. And therefore, there are a lot of short-term projects in it for summer students. And even you guys, if you are interested, you are by all means welcome to come this summer to our lab. And there are some funding opportunity that can fund your trip or for the entire summer as well as some stipend. They're called MyTax or ACSE in Canada. We can talk about those opportunities later. Anyway, one of the challenges, for example, with Oculus Rift, with navigational virtual reality, is that our brain stabilizes our gaze when we walk. We can look at the wall in front of us, and the wall doesn't move. But when we walk, our head moves slightly up and down every time that we walk. Okay, the Oculus Rift has a gyroscope. That gyroscope senses the head movement and updates the images, right? It doesn't have a brain to stabilize the gaze. So when you put the Oculus and you walk in the virtual reality, then you see the wall is moving a little bit up and down, and that is so annoying. With wheelchair, if you sit in the wheelchair, there is no problem. But if you walk without wheelchair, that is a problem. So that problem is going to be resolved this summer. I have 2 students working on it, undergraduate actually students. We have a couple of solutions for it. So this was just as an example that how large this virtual reality development can become. And there are some other issues to be resolved too. Okay. We also have RTMS treatment for Alzheimer patients. This is me. The person sitting on that chair actually is a student, just for the sake of photo, not a patient. We apply that RTMS, which is short for repetitive transcranial magnetic stimulation, to treat Alzheimer patients. So far, we have had 12 patients in the program. Okay. We also have some particular brain exercises to help Alzheimer's treatment, combined in particular with RTMS, because I believe it is the combination of brain exercises with RTMS that can be effective. Each one of them alone may not have a lasting effect, but when you combine them at the same time, it seems it is significantly effective. Okay. Now, I'm going to start talking about the sleep apnea and wakefulness. If you have a burning question that you can't wait until the end, please just raise your hand and stop me in the middle too, okay? And before starting, may I ask how many graduate students are in the audience? I know 2. The rest are undergraduates, correct? Okay. Okay. First of all, what's sleep apnea syndrome? Well, apnea is when the breathing stops during sleep. When it completely stops, it is called apnea. When it is significantly reduced, our flow rate, it is called hypopnea. If this apnea or hypopnea lasts more than 10 seconds during a sleep, then it is called an apnea-hypopnea episode. If it is very short, less than 10 seconds, it is not important. It is not called an event, but it should last at least 10 seconds in order to be called apnea or hypopnea episode. And usually this stopping breathing is associated with a drop in the oxygen level of the blood. So the definition of a sleep apnea episode is basically when the breathing stops for 10 seconds and the level of oxygen saturation of the blood drops more than 4%. Obviously, if somebody has frequent apnea or hypopnea events and the oxygen level drops quite often, then it can be quite a serious syndrome because the brain doesn't receive enough oxygen. Then after a while, it orders the body to wake up. So these patients who have apnea, hypopnea, quite often they wake up, even though they don't remember that they have been waken up, and that causes daytime sleepiness. There are three types of sleep apnea. One is called central apnea, which is due to the neurological issues, but that is very rare, it's about 5%. And obstructive sleep apnea is the most common. It is a population, about 85% of people have obstructive one. And also some people have a mix of the two. And it is quite common disorder in people over age 50, especially in male population. So one of the risk factors is actually just the gender. If you are a male, you are more at risk to have a sleep apnea. And it is massively underdiagnosed too. So many people complain about daytime sleepiness and problems with the breathing, but they're not diagnosed with a sleep apnea. Okay. How does it being diagnosed? Is the gold standard is PSG, polysomnography, which they connect about 15 different channels to the patient, as you can see in this picture, and they record EEG in order to find out the sleep stages. They record ECG, the heart signal, leg movement in order to see if the patient has insomnia or not, and airflow, snoring sounds. About, as I said, at least 15 channels. Okay. There are many portable devices too. In the last 20 years, many companies have developed monitoring sleep apnea devices that they range from 3 to 7 different channels. Some of these monitoring portable devices, patient can take it home without supervision. They can record their breathing at night, and some of them still has to be in the hospital. When we started research in this field, as usual, we are engineers. We thought that, okay, if we want to bring something new into the field, let's reduce the number of channels. Let's have it a very simple device that still can detect apnea, hypopnea with a high accuracy, but not as many channels. So we thought, and since I was working in the sounds, we thought analyzing the sound should be relatively easy to find out when the breathing stops. When we breathe, we generate breathing sounds. And sure enough, it wasn't that difficult. And we developed our first patented device, which is called ASAD, ASAD, short for Acoustic Sleep Apnea Detection System. We record only tracheal sounds, microphone located over suprasternal notch, over trachea, and oxygen saturation level by the finger clip. Recently, we are working on recording oxygen saturation actually inside the mouth so that we don't even need finger clip. Then we developed a software to analyze the sounds over the 8 hours night. We had to deal with the noise reduction. During the night, there are many other noises like swallowing noise, like snoring for sure, tongue movement, changing position. All of these create some sounds. So the program had to have a lot of noise reduction. And we detect finally the sleep apnea, hypopnea index. And the accuracy was pretty high. Okay. As I said, during a sleep, by sound analysis, detecting apnea, hypopnea, no big deal, I would say, right now. Yes, noise reduction was an issue, but overall, relatively easy. Then we became ambitious. We said, how about detecting a sleep apnea during wakefulness? Can we do that? When we started this idea, many physicians looked at us with a raised eyebrow and said that it is impossible to do. Why? Because people who have a sleep apnea, they don't have any problem during the wakefulness. They can even do exercises without any problem. They are not like asthmatic people who would wheeze and puff with exercise. These people are totally fine during wakefulness. But I'll tell you why we hypothesize that we think that we can detect it even during wakefulness. Before going there, I must say that there are some other groups in the world that also use sounds in order to detect apnea during wakefulness. One is the group, our colleague Raymond Jane in Spain, and they use voice analysis. They will use voice of people who speak and detect if they have apnea or hypopnea. I think they are detecting snorers, but that's an argument between me and Raymond. There is another group in Israel who also use voice analysis as well as the breathing sounds. They want to detect the apnea. We have a special session in this forthcoming EMBS conference in August dedicated to this particular topic. Okay. What is the rationale for detecting during wakefulness is that we know that people who have apnea, they have a narrower, also a more collapsible airway, even during wakefulness. And the reason that they can still breathe and exercise with no problem is that they compensate for this more collapsibility by the increased activity of genioglossus muscle. It is called GG muscle. It's the muscle beneath our tongue which dilates the airway, opens up the airway. During wakefulness, it seems that these people have an increased muscle activity, GG muscle activity. Okay? And it had been shown that their frequency response of the breathing sounds have different spectrum. It was a very small study, actually, with a small population that they showed. But this was initially that encouraged us to go through wakefulness study. Okay. These two X-ray images are showing one belongs to a normal person, which is, oh, you don't see the mouse. Yes, this picture belongs to a healthy person, normal subject. And this belongs to a patient who has sleep apnea syndrome. And both these two X-rays are during wakefulness. As you can see that the airway of the patient with apnea is much narrower. And also, it is not, if we consider a normal trachea as a homogeneous tube, which is not, but for simplicity, assume that, the trachea of the patient with apnea is definitely non-homogeneous. So the key point is exactly actually this homogeneity or non-homogeneity that I said. If we have a tube, which this tube is collapsible more than a normal tube, and it is non-homogeneous respect to the normal tube, then you can expect that when the air flows through this tube, then you may have some vortices. And the flow would be turbulent, not laminar flow. So if this is true, we should be able to see these differences in the sound analysis. And I would expect to see it in biospectral analysis, not just a spectral analysis. Okay. So we started our experiment recording sounds during wakefulness in two positions, two breathing maneuvers. The positions were upright and supine. So we asked the subject first to stay upright in sitting position, and then we asked them to lie down, and we record again. In each position, we asked them to breathe once through their nose and once through the mouth. Why do we do so? Again, because think of our airways like a bunch of tubes, like communication channels. If there is a narrowing in some of these tubes, by breathing through the mouth, you are bypassing the upper airway, nasal airway. So you will only have mouth and trachea beneath. And by breathing through the nose, you have the entire airway. So the differences between nose and mouth breathing, I would hypothesize that should be different in apneic and non-apneic people. We also ask them to breathe quite deeply, because when we breathe deep, we need more negative pharyngeal pressure, and that should bring up the abnormality even a little bit better. So we record four different signals. Then we analyze inspiratory, expiratory phases separately, because inspiration is active process, expiration is passive process. These two are quite different than each other. The sounds are different too. So we have basically 8 signals from each patient. Okay. Next is separation of the phases. We don't record flow. So we don't know exactly which one is inspiration, which one is expiration. We have to use sounds to do that too, which was the topic of one of my master's students. He finished, the entire thesis was on just detecting inspiratory and expiratory phases of the tracheal sound only by acoustic, only from the sounds. The behavior of the flow is a little bit different, so you can expect that it should reflect in the sound too. In fact, the accuracy is very high. But for this wakefulness study, we did it all manually, not automatically, just to ensure 100% accuracy. Nevertheless, we ask our subjects to start breathing from inhalations, and then it alternates, so we were sure that which one is which. Okay. Then, from the sounds, from each inspiratory, expiratory phases, we calculate a lot of features which you guys should be familiar with. I assume that you all had signal processing course. So the very first common technique is to use the spectral analysis, which means taking the Fourier transform, and then from the Fourier transform, you calculate the average power in different frequency bands. You can calculate crest factor. You can calculate even fractal dimension from the sounds. So we calculate all of those spectral and fractal dimension features. We also estimated the bispectral. Bispectrum is higher order statistics analysis of the sounds. Again, why to which I believe, in fact, the study showed that too, that the bispectral features were the most important features. And that didn't surprise me, because remember that I talked about more collapsibility, more, non-homogeneity of the airway. When there is non-homogeneity in the airway, then you expect the airflow have some vortices. Those vortices, the effect of those will not be detected by the spectral analysis, but you can detect it by bispectral analysis. When you go to higher dimension, you can detect the phase coupling in bispectrum, but not in the spectral analysis. This is an example to show. This is the bispectrum of somebody who doesn't have any apnea. AHI stands for Apnea Hypopnea Index. And AHI 30 means that they have had 30 episodes of apnea hypopnea per hour. And this is the biospectrum of a patient. as you can see, it is visually, they are quite different. But I must also say that not everybody had such a beautiful difference between the two. The population is extremely heterogeneous. Okay. So remember we had 8 signals from every patient. Then from every signal we had inspiratory, expiratory phases, then we had 5 different breaths, then we extracted so many different features from every phase. So the number of features almost increased exponentially, huge. How to do feature reduction? Well, the first one was run a statistical analysis, and the features were those that were significant, take those. Many of the features passed the 1% confidence interval, 99% confidence interval. So still there were too many. And also our features are correlated. They were not independent from each other. So we needed a different method again to reduce the features. Then we ran, I didn't write it here, I guess. We ran minimum redundancy, maximum relevancy. It is short for MR technique, to rank the features, and we selected the top 15 features of that algorithm. This is a very pilot result that I'm showing here. Not too bad in 2 dimensions, for example, just showing that how different the 2 groups of severe apneic and non-apneic people could be. But when we bring people with mild apnea, then the classification becomes much more difficult, because apnea has a spectrum from 0 AHI to even 100. Some people are severely apneic, some people are not. So we tried to group them into no apnea, mild apnea, moderate apnea, and severe apnea. And sure enough, when you do that, the population is extremely heterogeneous. They have a lot of overlap. Okay. But so when we increased our number of population, more and more people we got, the accuracy was not as high as we expected, because we saw that many people have overlapping features. And keep in mind that the goal was not to show only association between sound features and apnea. We wanted to classify. But classification in a heterogeneous population, well, is very challenging. Okay, let me, for the sake of time also, let me pass a few slides. Okay, here. We did try all the classic classification methods, like LDA, QDA, training, testing, tenfold cross-validation, all of that. And they failed. Quite miserably, actually. So we had either to give up the idea or keep digging into it. Well, I thought, I don't mind to give up the idea at some point when we exhaust whatever we can do on this. But let's try at least a little bit more and see what happens. The reason that they fail is that we are analyzing the sounds, and the sounds, it is not only apnea, airway structure that affects the sounds. There are many co-founding variables like smoking, the height, weight, BMI, gender, age. All of these affect the sounds. Smoking in particular changes the sound. You know that the smoking changes the voice. So obviously, smoking changes the breathing sounds too. So we are not dealing only with one variable. We are dealing with another dependent variables that are affecting the sounds, and we don't have the luxury to, for example, I don't have 1,000 subjects to be able to detect, to have a homogeneous group of population. So far, we have had 300 subjects, 300 people with and without apnea. These 300 definitely is not statistically enough to cover all the variability. This table shows the subject information. I know that I don't have enough time. I spent too much time on the introduction. So let me just say what classification technique we used and final results. Instead of classical classification, I suggested to use a voting classifier. I said, well, we are going to do a diagnosis, so let's act like physician. When a patient goes to a physician and say that I have depression, they look for existing of 5 out of 9 symptoms. If a patient has 5 symptoms out of 9, they say that yes, it is depression. So why don't we treat our features like a symptom? So I look at the features, every single feature like a symptom. If the majority vote for apnea, then I would say that is apnea. So we designed a classifier called voting system. Every single feature used an LDA classifier, and then we got the majority vote as the final decision. But even that, we designed a 2-stage classification and sort of an expert classifier. We said, since the population is heterogeneous, we said, let's design a classifier with voting system that is expert to detect non-apneic people, and another classifier that is expert to detect severe apnea. Then form a truth matrix like 0, 0, non-apnea. 0, 1, 1, 0 are ambiguous, and if both classifiers say that, 0, 1 and 1, 0 means either apnea or non-apnea, and the other 2 situations are ambiguous. Here. So I have one expert classifier, which is a voting classifier as well, that only detects non-apneic. And I have another expert classifier that only detects severe apnea. If it is 0, 1 or 1, 0, I know what is the result. It is either non-apneic or severe apneic. The cases of 1, 1, 0, 0 are ambiguous, but then again, on those 2 cases, we went with the probability of those votes. We looked at what was the probability, how strong was the vote, and assigned a grouping based on the probability of the votes. And this is the results so far, based on how many subjects? I didn't write the number of subjects here, but this is based on, I think, about 250 subjects. And these accuracies are based on 10-fold cross-validation. Well, it is not excellent, but it is not bad either. I mean, we can live with this accuracy. After all, remember, we are doing some sort of prediction during wakefulness. If I can say with an accuracy about 80%, 75%, who is having apnea, then we can refer that patient to full night sleep study. That was the goal, that we come up with a technique to screen patients at physician's office, 10 minutes recording. And one of the motivation was that many of these people who go for surgery, they don't know about if they are having apnea or hypopnea. And we know that the complication of the respiratory arrest after the surgery is much more often in people who have apnea and they have not been diagnosed. So, and there is no time before surgery to go for full night sleep study. So we thought such a quick technique, at least it can screen them to see if it is likely that person have sleep apnea or not. So an accuracy about 80%, I'm arguing that it's something that we can live with. But of course, I believe if we increase the population, if I bring the smoking, non-smoking background, if I can allow that feature into classification, the accuracy may even go higher. Okay. Well, as I spoke about the heterogeneity of the population, the cause of OSA is quite different. Not necessarily everybody who is old having OSA, obstructive sleep apnea. Some young people do have it too, due to ethnicity background. Some people, some tribes have a jaw that their jaw by default makes them to have sleep apnea. For example, some young people snore too. Usually snorers have a sleep apnea, but not necessarily every snorer is apneic. Again, this is another variable that we haven't been able to look at that because we don't have enough subjects. If we have about 1,000 subjects, then I would say we have to group them based on their ethnicity background, based on their gender, height, weight, BMI, as well as the smoking history. Then design our expert classifier for every group with matching anthropometric information. Then the accuracy can go high. That's why that we are still continuing the results. The advantage, well, it reduces the healthcare cost significantly, because 70% of population who go for Ph.D. overnight study, they turn out to be either mild or no apneic, and they don't need treatment. So why bother with the full night sleep study? If this technique is being optimized for the accuracy, then we can probably make it an iPhone application. It is so easy. We can ask a patient to record put the iPhone here and just breathe. If we can detect it by just breathing analysis, and it gives, as I said, an accuracy about 80% would be good enough. And besides, we don't need that many positions of recording. We can optimize it and reduce the number of positions, number of recording as well. So eventually, I envision it to be an iPhone app, basically. By the way, the iPhone microphone is excellent. It is a $4 microphone, but it is an excellent microphone. We ran a study to show it that its sensitivity is excellent. And also, as I talked about the surgery issue, it is a quick screening tool before the surgery. Okay. The current and future studies. Right now, we are looking at sound analysis during both sleep and wakefulness to see which features shows the most significant changes from wakefulness to sleep. Therefore, maybe that way we can optimize it better. We are looking at the flow-sound relationship between wakefulness and the sleep. We have seen some very encouraging result here that this parameter changes due to apnea. But that's an ongoing study. Okay. Our study has been supported by NSERC, National Research Council of Canada, and we have had 2-3 patents on it. Dr. Eleni Giannouli, who is, by the way, a Greek nationality. She's in Canada, but she's the one who has been my medical collaborator. And we recorded all data in Misericordia Hospital. This is not my current team. Yeah, the majority of them are still our current team. I haven't updated it. There are a few who are missing in this picture. And the students who worked on this study were ASAD, then Aman, then Dawood, and Cam. Cam was an undergraduate student who worked an internship. He designed those expert classifier. Very bright student. He's going to start his master this coming September. And yes, and he's also working at the moment, a PhD student, Ramin. Okay, I would be happy to have your questions.
Thank you very much. Υπάρχει δυνατότητα να κάνει την ερώτηση στα ελληνικά και να τη μεταφράσουμε στα αγγλικά. Οπότε, έχετε το λόγο.
Let's see how many people have slept. As we talked about the sleep apnea. How many snorers do we have in this room? How many of you know that you snore? Well, I'm a little bit surprised. You guys are young. Do you know why you snore? Why? Okay. When you're tired, that means your muscles are tired, so your genioglossus muscle fall back, doesn't dilate, and that's why that you snore. Alcohol also causes the muscle to relax too much. That's why that if you drink too much at night, then the more you may snore. Sure, please.
You are planning to make the application for iPhone, right?
Sorry, say it again.
The application. Will you also transfer it on Android later?
Once it is optimized, yes. Why not? As I said, it is very simple recording. All it is signal processing. Recording is extremely simple. It can become on Android too. Nobody is interested to know about the treatment? Yes.
Before you said that you had something like 7 channels recording some signals. Am I right?
Say it again.
You said that in the first stages of recording like signals,
yes,
so that you can make something like a conclusion for your studies. There were 7 channels, and after that you tried to simplify it by reducing the channels.
Reducing the what, sorry?
The channels that you were recording. My question is, what did each channel record?
Oh, okay. The very first one that I showed, right?
Yeah.
On the ASAD box you're talking about,
yeah,
during
right.
sleep, I see. That was 2 channels, 1 sound and 1 finger clip oxygen saturation.
Yes, but
for the sounds, we only record 1 channel.
Okay, but before that, you said that there were more channels, and that's why you decided to simplify it.
That's right, yes.
Yeah. What did those 7 channels record?
Usually they record EEG, at least 2 to 4 EEG channel, because they want to know what is the sleep stage. A sleep stage is important because it is not only apnea-hypopnea index that is important. Some people have apnea, but they don't wake up too often. Their metabolism is different. They have a chemical drive that their body compensates, and without waking up the subject, the patient, they go to a state that they get out of the apnea-hypopnea. So a sleep stage is important to know from clinical point of view. It's important to know in order to determine if the patient needs CPAP machine for treatment or not. So those channels involve 2 to 4 channels of the EEG. Some of the monitoring devices use heart rate as well, because some people use heart rate variability to detect apnea, hypopnea, which is quite a robust technique as well. So it depends what is the devices, but usually ECG, EEG, oxygen saturation for sure, and nasal flow.
Thank you.
You're welcome. Yes.
Hello, good morning. I am a biomedical engineering student, and my question is, does the data that's recorded, for example, by the app you mentioned, does it still require human interaction to diagnose apnea, or does the data processing happen in the phone, for example, and it right away gives out the result?
This wakefulness.
Yes.
Well, our programs are not online. I mean, it needs processing. At the moment, it is not ready to be in clinical physician's office because it is at research stage. But I envision this one, once it is optimized, it can be written in C++, for example, and the program processing time would be not much. The reason that at the moment it takes time is because we extract too many features, and then we run cross-validation, all of that. Once you are sure about the features that you want to detect, then you don't need to do this much calculation, and it can be, the processing time, I would say, would be less than 20 seconds or so. That's the time that would be going to iPhone. But if you have an entrepreneurship mind and you want to go to the R&D industry, you may, I'm suggesting a different business model for it. Because, it is not good to put the algorithm inside the iPhone. It is better to keep the algorithm in a server and just ask the patient to use the iPhone, for example, or Android for recording, and then the data is being transmitted to the server, and every time that they do this, use this one, therefore pay a service fee. That's the business model.
All right, thank you.
You're welcome.
Hello, my name is Alexa Tumba, and I'd like to ask something about the treatment. I guess that surgery isn't necessary, and taking pills, I guess that would be my thought, taking pills for the treatment, but what's the impact that the pills would have for each patient?
I'm glad that you asked that. Yes, I was hoping that somebody asked about the treatment and I talk about it. There is no pill for a sleep apnea syndrome. Thanks God that there is no medication for it. Medications are in order to increase the arousal threshold, which means that to make some people to sleep, to wake up at a higher level so that they don't wake up too often. So for some people that might help so that they are not waking up too often. But there is no medication for it. The treatment, the common treatment is a machine, CPAP, positive pressure. They sleep with a mask and they receive the air being forced to their airway. Since the air is being forced to the airway, it keeps the airway open. And that is called the CPAP. There are different types of CPAP. Some is a full mask. Some of them are a small, even only for the nose. And some patients love CPAP. They travel with their machine everywhere that they go. And some people hate it. The response of population to it is quite different. For people who are severely apneic, they have no choice basically than to use CPAP. And as I said, some people like it. With CPAP, you're connected with a mask and a tube to the machine, so rolling over is not easy. sleeping next to a spouse is not easy either. Maybe that's why that people hate it. You ask about surgery. Surgery, yes, I thought that nobody would go for surgery due to snoring and the sleep apnea. And my colleague in US told me that you're wrong. Many people come because they say that snoring and apnea is ruining their relationship. So they go for the surgery. But the truth, or at least the literature review, the papers that have been published, they show that the effect of surgery is not as rosy as they claim. It is only 50%. And also it comes back. And surgery is effective for people who have apnea due to the palatal apnea. Means that they have obstructive apnea due to a heavy tongue, that the tongue falls back and obstructs the apnea. It is not effective for people who have nasal obstruction or behind the nasal cavity obstruction. There is yet another surgery for those people, which is less major. And again, the effect of that is also questionable. But there's still many people, there are people who take surgery too. And there is yet one very simple treatment for people who are a snorer, young people who are a snorer. This is not my suggestion, actually. Dr. Mehdi Yunus, who is a world-known sleep apnea physician, he's quite famous in his field. He was suggesting the best treatment is opera singing, or to stick out your tongue 3 times a day, every time for 30 seconds, as much as you can. Stick out the tongue, completely out. Yeah, it looks awful, but do it in a bathroom, and remember to, each time you have to hold it for 30 seconds. It hurts the throat, actually. And by doing that, what you're doing, in fact, you're exercising your genioglossus muscle. And you know that each muscle of the body, if you exercise, they become stronger. The fact that people are a snorer, it means that their genioglossus muscle is losing its rigidness, its stiffness, and it is becoming collapsible. If you exercise that muscle, the problem is resolved. So that is the best treatment, the most simple, best treatment, basically.
Thank you very much.
Rob.
I will ask the last question, perhaps. You're dealing with Alzheimer's also, patients. Have you thought of combining the sleep apnea effects in the Alzheimer's patients, and if we go more to the future, use an iPhone to detect the relationship with Alzheimer's through breathing?
Very good question. I don't think sleep apnea causes Alzheimer. Cause and effect is different than association. But I do think that sleep apnea and Alzheimer may have an association, but not that apnea causes Alzheimer. In fact, apnea doesn't cause anything, but it is associated with many other cardiovascular diseases too. It aggravates the situation. For Alzheimer also, having severe apnea is known that is associated with dementia, with forgetfulness. Obviously, if we don't sleep well at night, we may become forgetful during the day. So you can expect this type of association. One study that we have done only one, I told you last night, and we are going to continue, is to look at our Alzheimer patients' sleep data. In fact, to look at their EEG data more than apnea, not much apnea. Some of our patients are apneics, but there are a few who don't have apnea, who don't have need for treatment. But it seems that their EEG signal is quite different than normal population. In fact, the difference that we have seen, but I have seen it only in one, is the asynchrony between left and right side of the brain in the 2 hemispheres. I'm not sure if we will see it on other subjects or not. But it is good to look at their EEG during sleep as well as apnea in association with Alzheimer. I don't think anybody has done it though.
Okay, thank you very much again.
Thank you.